vicino. Sono arrivati, sono concentrati. Fammi le senti che questo Everything are operated out of this room. Right behind you is the chief engineer of the Mardi Gras, Fernando Rocca. Nando's been with this project for many, many years. First time I met him was in Almere at C-Smart, where we were working on some environmental aspects around LNG. So he's been with us from the very beginning. Took a little bit of extra training, so we had the good fortune of sailing with some of our sister brands that had LNG ships before, so that he could get additional training and familiarization. We have our own LNG training simulators at C-Smart in Almere, so a lot has gone into preparing for this. And so far, everything has been flawless with all of the various bunkerings that we did in Europe, Port Carnival, and in Miami as well. So we had the honor of being the first passenger ship that's fueled by LNG to bunker in the United States. Well, actually in all of North America. So the engine control room, one of the things I think people may have in their mind that the ships are being pushed by an engine that's connected to a shaft that goes all the way back to the propeller. But for many years, cruise ships have effectively been known as what it's called the diesel electric plant. This ship has 4 generators that are fueled by LNG, and all of that electricity that those diesel engines generate goes into a system, and then that power is apportioned out to whatever consumer there is. So it could be the propulsion, could be air conditioning, could be galleys, laundries, the lights, the TV in your staterooms. Okay, so there's really no direct connection between the engines and the propellers. The ship has 4, is it 18 Vs or 16 Vs?
16.
So the ship has 4 engines that are a V configuration. There's 16 cylinders. Each cylinder is probably yay big. These are 50s, right? Chief, they're 50s, right?
48.
48. So each cylinder is 48 centimeters across, almost half a meter across, and each engine has 16 times 4 engines. So a lot of power is possible to be generated on board. Let's see, how many do we have running right now? We have 2 engines running.
Yes, we have 2 engines running. You can see that here is the page with the data of our one of the generator running. No, number 2.
This one is under maintenance.
Number 4, for example. So from here we control all the data and the information for each generator.
So diesel electric, sorry.
So you have the network. You can see number 3 and 4 that they are connected to the network, the green one. Number 1 and 2 they are on standby, and here we can see all the network at 11,000 volts. That is the blue line, and the supplier to the main pods, the propulsion motors.
So by far, especially for passenger ships and cruise ships, using a diesel electric approach is the most efficient way to run the engine, because all diesel engines have kind of a most efficient sweet spot when it comes to how much power they're putting out. And so you want to match how much power that you have available on the bus, right, or in the system to that's being requested. You don't want to overproduce, and you certainly can't underproduce, right? You'd have a blackout. So this allows the chief and the engineers who are running this to match what's available and generating with what's required. LNG it can't even self-ignite. The auto ignition temperature is so high that even with compression in a diesel engine, it's not enough to auto ignite. So we actually spray a little bit of MGO into each cylinder, and it's effectively the spark plug for getting the LNG to ignite and combust. The temperature is about 259 below 0 Fahrenheit, or 150-ish Celsius.
You can see one of the tank, another tank. You can see that we have the liquid part. Let's say this is the level of the tank. So this is a tank that is around 40% now on level. So the liquid part is at minus 155 Celsius.
Okay.
And the vapor side is 153. So they're very close.
And I'm not sure how many days or weeks you can go on MGO, but it's a significant amount of MGO.
More or less it's the same amount. Let's say the capacity on MGO is still for a couple of weeks.
Yeah. So lots of fuel, both the liquid and then the gases. So obviously, liquefied natural gas is basically cryogenic methane. As a marine fuel, it ticks an awful lot of the boxes. So obviously, over the last 20 years, there's been a lot of effort to reduce the amount of sulfur that's in marine fuels, as well as on train and automobiles and trucks, etc. So you can see the slowly stepping down of the allowable amount of sulfur in fuel. There's two regimes that are global. There's the global cap, which today is at 0.5%. And there is an emission control area, which is around North America and a significant part of the Baltic and the North Sea in Europe. There are also many, many local ECAs around the world. Effectively, California is one. China has several. The European Union has established effectively import ECAs. So this was a big driver to, to get to compliant fuels. Next, Chief. So what does it give us? So it has a significant, LNG basically removes sulfur dioxide because there's simply no sulfur in the fuel. It reduces NOx just because of the characteristics of LNG when it combusts in the engine, so we reduce NOx by about 95%. And again, since there's no sulfur in it, the particulate matter that is emitted from other types of diesels is effectively removed as well. So SOx is when you think of SOx, think of acid rain because it creates sulfuric acid in the atmosphere. NOx is smog and haze, like you think about California in the early 70s. So one of the big things, obviously now carbon, climate change, global warming is obviously in the forefront of a lot of the work that's going on at the International Maritime Organization. So as you can see, LNG also ticks the box when it comes to climate change and global warming and trying to reduce our carbon emissions. So the diesel fuel and heating oil is basically what we have in the MGO on the ship. And down below you can see natural gas. So you can see how much lower the ship is just so for like emissions. LNG puts out 27.5% less carbon dioxide for the same amount of work, right? So that's certainly a win for us. It does all the other air emissions tasks that we needed to do as well. Amen.
Okay.
So this was, you guys were on board. I took these shots while we were underway. Those are clouds, that is not smoke. The one on the left, you can see there's effectively nothing. There's no smoke, there's not a mist, there's nothing. You can see the heat waves coming out. So when you're out on the upper decks, take a look up there and you'll see what I mean. This is what LNG provides for us. And this is just a quick schematic of the fuel system in the engines. You can see the 3 LNG tanks and the 4 engines, and those things that stick up are venting lines. Any questions on the fuel? I mean, obviously that's a huge part of the ship. Big win for me. I mean, I've been doing environmental for decades, and it's really the bridging fuel for the marine world. Sir?
Yeah, so LNG, I understand, is not the most cost-efficient method or solution. Does that add to the cost of fuel for Carnival?
I don't know the financial side of it. From what Rich knows, I think the upfront costs were probably higher. So the CapEx might have been higher. But especially in the United States, LNG is cheaper than it is in Europe. So I mean, Mr. Arison and everybody and Arnold Donald are pretty smart businessmen. So if we hadn't seen the benefit, both financially, environmentally, probably couldn't have done it. The amount of safety that's built into the ship is enormous, and I am not the expert on that. But there's an entire international code on how you build and operate, maintain ships that use gas as a fuel. And remember, we've been moving LNG around the world for decades and decades and decades. And a lot of those tank ships use some boil off from LNG to fuel their own engines, right? There are detectors, there are systems that we inert the tank spaces if there were to be a leak. So we would know there was a leak, we could inert the space. And the team, like I said, has gone through exceptional amounts of training to be prepared if that were to happen.
Yeah, I cannot, there is the perception that gas can be dangerous, but if you think that all of us at home we have a barbecue that run on gas, so it's nothing really new for our operation. The matter is that still now we have gas LNG on a passenger ship, but as Richard said, before building the ship or when they decide to use LNG, there were a lot of studies and preparation to build the ship. As Richard said, there is a dedicated code from SOLAS and IMO dedicated to this kind of ship to use low flash points fuel on passenger ships. So it's really such a high standard of safety, fuel and safety equipment on board. The ship is extremely safe. And on the other side, the training that we went through is part of this safety culture that we implemented to operate the ship.
But the low temperature makes it really a non-issue in terms of safety, from what I understand.
The low temperature can present different kind of, let's say, dangers or warnings. So make more easier to store the LNG on board. It's easier because the low temperature, the liquefied gas, we can store more gas, more fuel on board. Of course, we need to know how to treat it, how to deal with this cryogenic temperature. But as I said, the safety standards are so high that it's extremely safe to ship. To be honest, since like Richard said, I am in this project now. It's almost 3 years, and I love it. And all the team on board, they are so engaged, so happy about the LNG. And now for us, probably it's very difficult if we should go back to, let's say, more traditional ship with fuel. Probably we will not like that. No, we want to stay with the
You're the
LNG.
experts now on LNG, so I think you're staying.
We like it. Sure.
Rich, at the top of the ship, there's some stacks that you don't see on the rest of the fleet. And how do those relate to the LNG?
So those are the venting. That's just a pretty way of making the vents, just the aesthetics.
Okay.
Aesthetics.
So they could just be pipes coming up?
It's vent lines, yeah.
Yeah.
Exactly.
Okay.
The Mardi Gras, like all of Carnival's new build ships, going back to the Vista class and the Vista herself, we install advanced wastewater treatment systems on board, and effectively these treat all of the gray water and all of the black water to standards that are as good or better than most municipalities treat wastewater in the United States and frankly around the world. What you're looking at here is a grease separator, so all of the water that comes out of the galleys, for obvious reason, we run it through a grease separator or a grease interceptor, and we remove the grease and any stuff that comes from grilling and things like that. We take that out of the water. There's the next picture. This is just the lower part of it. It is so complex. I mean, it's unbelievable what it goes through to remove the grease, but it does a very good job. And the grease is landed in big drums, and the water, along with. Sorry. I feel bad asking them to do my slides. This is a sewage pre-screen. So what we do is all the black water on the ship comes down and goes through a pre-screen to remove toilet paper, feminine products, reproductive action stoppers that are coming down. I can say condom, we're adults here. So anything that somebody might flush down the toilet, it will stop it. Okay. And then that is landed, or it can be incinerated on board as well. So after these two pre-treats, it goes into a mixing tank. I can't really take a picture of that because it's just a double bottom tank that has air that's blown in to keep it stirred up. But after that mixing tank where we blend the gray and the black water together, we run it through a pre-DAF, and DAF just stands for dissolved air flotation. And what that means is the water comes into the unit under pressure because we're pressurizing it a little bit with air, and this tank here is ambient pressure. So when the water enters this device, it's like opening a beer or a soda, and the carbonation rises to the top, and that carries any of the solids or particles that are in there to the top. And on the On another picture I'll show you, there's like a mechanical scraper that removes any of the solids that rises to the top. These are blowers that not only stir the wastewater up to keep it mixed, but also provides the oxygen, because this is an aerobic process, right? We wouldn't want it to go anaerobic because then it would start to smell. But we use beneficial bacteria that are aerobic, and effectively they eat the organic material that's in the water. That is, the organics are one of the problems that we have, because they can actually consume oxygen as they consume the organic material. And you may have heard of like hypoxic and anoxic zones off the Gulf of Mexico, the dead zone off of the Mississippi River. That's what happens when too much bacteria gets into an area and consumes all the oxygen. Well, these blowers provide that oxygen, so we don't have that anoxic condition that happens. Next. So after the bioreactor, we add a small amount of a polymer that basically helps to grab any of these particles that are left, and it creates flocks. So these flocks just come together. Just imagine a little cotton ball, and then it goes on to the second DAF, the second dissolved oxygen, dissolved air flotation system. Sorry, Chief's on the phone. And you can see this chain. This is the chain where you can kind of see a little bit of stuff that's floating on top. That gets pushed to the other end, and we can take a look. We'll climb up there. Anybody wants to climb up the ladder can take a look in. Yeah. And you can see about this far below the top layer of water, the top level of the water. That's the Weir. That's where the clean water, which is because all these things have floated to the top, we're removing them, and the clean water comes out of the bottom. But we're not done. This water is extremely clean now. We have removed all of the organics that you can't see, but it's not enough because we use ultraviolet light to actually disinfect the water. So we've sent it from here to a polishing filter. It's just another close-up picture of the water going over. These are automatically back flushing and self-cleaning polishing filters. These are 100 micron or 50 micron.
Yeah.
So the filter membrane is just like your shirt. I mean, nothing is going to get past this. And it's important because if we go to the next slide, these are the UV, the ultraviolet reactors. And effectively, these kill or basically make it so that any of the bacteria that's left, whether it came from us or was beneficially introduced early on, it makes it so they can't reproduce. So they die very quickly because their life is about 5 hours long, I think. So this basically inactivates them, okay? Because we don't want to put chlorine in. Of course, we have to use chlorine in the potable water in the swimming pools. It's a US pH requirement, but we don't want to use it to disinfect the wastewater. And this system allows us not to do that. And so from after the ultraviolet light, like today we're underway, this water can go directly overboard as long as we're outside of any restricted waters. With this system, we could, under international law, we could discharge at the dock. If we were in Alaska and we went through all the permitting, we could discharge at the dock in Alaska. This system was built and designed and is proving itself to be ready for both the Baltic special area for nutrients, as well as the Alaska standards, which are multi. Okay, this is the laboratory that we have on board. The engineer who's responsible for the system goes in there and runs tests on the wastewater periodically. So in the previous, you saw that plastic tube that comes down. That just comes from a sample port. He takes a sample of that water. We take it to the laboratory and we run it against these types of analytes. So I mentioned BOD, or biochemical oxygen demand. That's how much oxygen is consumed by the bacteria when they eat the organics. Chemical oxygen demand is similar, but it also includes the chemical aspect of it as well. Turbidity just means how cloudy is the water. pH, we all know pH. Fecal coliforms, again, those are bugs that come out of the mammalian gut. And dissolved oxygen, which is a process control. Because remember I said this is an aerobic process. We have to make sure that we have enough oxygen being dissolved into the system. The bioreactors are about 4 meters tall. So that gives us a nice water column to try to saturate the water with this air that's being blown in.
Where on the ship does the water actually get discharged from?
There's a discharge port, aft. Obviously, it's aft of any place that we take water in, right? Everyone asks that question. It is aft, so you will never drink this water. I promise you that. And even if you did, it is pretty much drinking water quality. Plus, it has to go through the reverse osmosis or the steam evaporators. So, but it's not going to happen. Never. I get asked the question, why don't you reuse the water? The question is because our water production systems are so efficient, it simply doesn't make sense to worry about having a triple barrier to reuse water for drinking water. It just doesn't make sense. Too many risks, and it's so efficient, so we just don't do it. Any questions on wastewater? Okay, so we have some other waste streams that are, water or liquid based. This is an oily water separator. It uses centrifugal force and takes advantage of the specific gravity difference between oil and water. Just like gravity separates out oil, centrifugal force does the same thing. So it just spins at thousands of RPMs, and the oil goes out at one part of the bowl and the water goes out of another. All of our oily water separators come with their own oil content meters. We also have a what we call a static oily water separator, which uses gravity, heat, and also uses a filter cartridge effectively. Okay? It also has an oil content meter. So these have to reach 15 parts per million or less. I can assure you that 15 parts per million is invisible to the naked eye, but the oil content meters use various technologies, fluorescence, refracted light to actually, it knows that oil at a certain frequency of light will bend at a certain angle, and it knows what's oil and it knows what's bacteria and it knows what's just dirt, right? So these are those oil content meters are very sophisticated and very accurate. These are the white boxes. So because we don't want to rely on just the oil content meter on the oily water separators, we use a secondary analysis system, again, made by a company called Flock, but we affectionately call it the white box because that's what they called it. This has an oil content meter. It has a flow meter to tell us exactly how much water we're sending over. The oil content meter has a system where if it detects that the oil level is too high, it will send it back to the system to be reprocessed again. So we have every drop of water, every drop of bilge water gets 2 looks to make sure it's compliant. Now you might wonder, what is bilge water? Bilge water can be any kind of water that's in the bilges. The bilges are just the furthest, lowest down point in the ship. You think about bilge water, people think it's really black and oily. It's really not. The ships, first of all, from a safety standpoint, we would never allow oil to drip into the bilges and stay there. So whether it's fuel oil or lubricating oil, if we find a leak, it gets stopped immediately, right? What you're typically going to find in the bilges are drips maybe from a seal on potable water or seawater pumps. And also, depending on the temperature outside and the seawater temperature, all that air that we're blowing in to ventilate the engine room and to provide combustion air for the engines is high humidity. We've been walking around outside, we know how humid it is. If the air is 90 degrees and it's 100% humidity and you push it down to seawater that's 82, it'll condense on the hull. So some of the water that's bilge water is also just condensate. Okay. And we also have a program that's in place now where we call it the dry bilges program, where we go and we divert anything, even with like potable water samplers. They used to just go into the bilge and it would become part of the bilge water. Today we divert that and capture it. So we generate, for a ship this size, less than 200 gallons a day for a ship of this size. It's enormous, and that includes all this condensation water and little drips, etc. Any questions on bilge water? Okay. Ballast water. Ballast water is the water that we use for stability so that the ship doesn't get a little bit top heavy. We also use it to trim. The ship is probably most efficient. The hull design is probably most efficient when it's down maybe a half a meter or a quarter of a meter down at the bow versus at the stern. So we use it to trim. We also use ballast to counteract any kind of a list. Let's say you're driving along and the winds are pushing really hard from one side. We have ballast water we can transfer from left to right to keep the ship on an even keel. We've all heard that term before. Works on a ship just like it does with us. Keep on an even keel. We also have healing tanks that we use, but those are a little bit more fine-tuned. So if the guys on the bridge feel that we're leaning to one side or the other a little bit, they can do very fine movements of water to make sure the ship stays upright. It's from an efficiency standpoint, but it's also a comfort, right? Nobody wants their whatever it is to roll off the table. Okay. So this is just the control head. So ballast water treatment works through really two things. One, we filter it. So we have a self-cleaning automatic back flushing filter that if there's any vegetation or any small organisms get sucked in, the filter removes them. And of course, since we're basically back flushing them in the air, we pick them up. There's no threat of transferring some type of an invasive species. The other thing that we use is ultraviolet light again. We use ultraviolet light to kill any organisms that are so small that they get through the filter. Now, why is ballast water a concern? I don't know how many people are from Florida or from maybe the Midwest, but you have what's known as invasive species or non-indigenous species that you can pull up in one place and you can discharge in another. Now, the good news is with cruise ships, we typically only take on ballast to make up for potable water that's consumed or fuel that's burned, right? This ship is what I would like to call is operationally ballast free. The ship is so stable that we will never discharge ballast in port. Many of our ships are that way today. They just use the weight of the ship and fuel and potable water and gray water and black water and just the weight of the equipment that's on board to maintain the stability that we need in any condition in port, right? So many people have heard about lionfish, maybe zebra mussels, the Chinese snakehead. We don't know if they definitely came in ship's ballast, but it's both from a flora and a fauna concern that we simply don't want to pick something up and bring it to another. So we filter it out and then we zap it with UV to kill it. Or again, to make it so that it can't reproduce. Okay? Any questions on ballast water? Again, we're not discharging ballast water on this ship in port. So that's the best ballast water treatment is just don't discharge it. That's true of a lot of things, and I'll talk a little bit more about that. Food digesters. Now, obviously, what would a cruise be without food? We obviously generate a lot of food waste. You just have to look at people's plates afterwards. But there's also food waste from preparation and there's spoilage and things like that. I mean, our refrigerators are no different than yours. So we decided that we wanted to try to address this, and we've done a couple of things. We have a corporate-wide food waste reduction where we've already achieved, the last time we had guests on board for a full quarter, we had achieved a 20% reduction corporate-wide from where we had our baseline. So we're already doing a great job on that. But also, food waste, as you know, it either gets landed or it is chopped up, pulped up, and discharged to sea when we're outside of 12 nautical miles and we're underway. But we thought, okay, what can we do to further reduce the amount of food waste that we are discharging at sea? So we started looking at some technologies. In addition to these food waste digesters, which are effectively a stainless steel stomach, right? So, we use beneficial bacteria for a lot of things. I talked about advanced wastewater systems where we use it. We also use it here. So effectively, what you have in there is some media. We add in beneficial organisms that basically digest the food waste inside the tank. And those funny looking arm things there basically just agitate the food because these are also aerobic organisms. So we want to make sure they stay oxygenated. It also helps to get the bugs to the food. I'm not sure if we're going to be able to get into a galley today just because we're in service, so it's probably going to be difficult. But this is what they look like. They come in a couple of different models. So this is, we call it a mangrove. As a corporation, we have 3 manufacturers that we've gone with. This one is from a company called BioHightech. Carnival Cruise Line also has another manufacturer that is called Orca, where we have purchased these. And even during the pause, so even though there was no money coming in, we continued. We're still, committed to installing these things throughout our fleet. We're going to have around 226 of these when we're done, maybe plus or minus a few, because obviously as we get back in service, we might find out that maybe this ship has 1 too many and this one has 1 too few. So we're going to move them around, but we're shooting for about 226 in the Carnival fleet. And we're around 190-ish. It changes every day because I've got 2 teams out there installing these things as we speak. This ship has 14 of these, and we have 4 different models on board. Everything that one unit will eat 2,400 pounds of food waste a day. And I can tell you that because I watch an app that tells me what each one is eating and if there's any faults. So if I see a fault, I can call the food ops manager and say, please go check this machine out, find out what's going on. And one that eats about 600 pounds a day. So depending on the size we have available in the galley and how much food waste is generated, we build to suit, so to speak.
Sorry. What's that 1,200 based on?
1,200 pounds of food waste a day, 50 pounds an hour.
But like for this ship at full capacity, or?
Oh no, it's more than one. We have 14 of these on board. Now, not every
that's
galley
per machine.
Not every galley is going to eat 1,200 pounds of food waste a day. As you can imagine, you know, we couldn't go to them and say, I need a machine that will digest 672 pounds because that's what this galley digests. I kind of have to say, well, the next biggest one up, because I don't want to go too small, is 1,200 pounds or it's 900 pounds. So we intentionally went over capacity because we wanted to make sure that we had enough if we had surges, but also if a machine goes down for maintenance or repairs, I don't ever want to get below what I think my baseline is.
So just for fun, can you provide a ballpark on how much waste 70% capacity Mardi Gras produces?
Right now, our latest was 1.03 kilos of food waste per person per day.
What's it digested down to and what's done with it?
So what we put in here is anything that can be digested. So I'm not going to put an oyster shell. I'm not going to put a lobster shell. I'm not going to put a heavily calcified beef bone or something in here because it's simply, it might eventually break it down, but it would take up space. So if you put in there fruits and vegetables and meat and carbohydrates, pastas, rice, breads, etc., it will eat it down to where there's effectively just a liquid effluent. And depending on how much it's eating and what you've put in there, I've seen it from where the effluent is fairly clear to where it can be a little bit thicker, like a bisque. Now the ship just really got started. We just started the last 4 or 5 units just a couple of nights ago. So just like the bioreactor for advanced wastewater, these systems are living things. So even though we put food waste in there, we put the organisms, it takes them a while to adapt to the food and to adapt and start reproducing and building their own colonies. We periodically add additional organisms to make sure that they're fully stocked, but it's going to take probably a cruise or 2 before they really get up to where they're performing the way we expect them. So it'll go down to just basically a liquid effluent. Put it this way, the screens in the bottom of this, on one of them is 0.9 millimeter, right? And it takes 25 millimeters to make an inch, so that gives you an idea of how small the screen is. And these are 2.3 millimeter, this unit right here. So it's going down to basically very, very small. Yeah, so again, corporately, we made a commitment to try to reduce the amount of food waste that's going into the sea. We have other operating lines, and we may try it, are using dehydrators and dryers. So instead of digesting it, they dry it, shred it up so that it weighs very little, and it actually can be compacted into a small box and land it. Now, if you're operating in an area where you're in port every day, let's take a European line that's operating European itineraries, you're in port virtually every day, and they can land every day. If we're on an eastern, right, we can pretty much land maybe in San Juan, but we couldn't do that. Why? Because we would have had to have gotten a barge to come from the Bahamas because the ship, the dock doesn't extend to the doors where we offload. On the western itinerary, Cozumel, Costa Maya, Grand Cayman, there's 0 ports that we can offload. So really drying and compacting the food waste and offloading it really didn't make sense for us because we really didn't want to hold it all until we got back to Miami or Port Canaveral. So for us, digesters made the most sense.
Are you doing anything like on the, I guess, service end of the food waste to reduce waste? Are portions being a little bit more, right-sized? Or I know that we're still doing, you're doing self-serve buffets here on Carnival, and other lines have gone to serve buffets to
Right.
reduce waste. Is anything like that looking at reducing waste?
So that's really how we got to the 20% reduction. I guess it should be invisible to you, right? You shouldn't feel like, oh, they're being stingy with my food, right? But they've made adjustments, they've made improvements in the way, in the prep. We have a program that's called Don't Waste Your Waste, right? Where we're trying to minimize how much is there for prep waste, right? It's like being thrifty at home. If you're chopping something up, so, oh, that would go in a soup, or that would go in this, or that would go in that. So a lot of work has gone into that. Very careful about first in, first out, about trying to avoid spoilage, because spoilage, prep waste, that all counts against us when it comes to food waste. Okay.
Thank you.
So this liquid that is the end result of this process, does that go through a treatment process as well? And then do you get rid of it somewhere?
So right now, it's not, because we have to wait for the advanced wastewater system to stabilize, right? Because remember, we went from around 1,600 crew members on board. Saturday, we had 4,200 guests that came on board in addition to the 1,600. So once the AWP plant settles in, the plan is to move that in there as well. We have to be careful, because we can't, if we shock it, it'll start to foam and do some other things. So we have to, it's a process. It's a phased in process that we have to slowly work these things in, but that's the plan. It's actually not a lot of liquid either. So I don't want you to think it's truckloads and truckloads. It's just not. The other thing is it comes with its own, and they continue to digest, even because the organisms stay in this effluent, and when they go down into the tank, they're still kind of digesting the food. The other thing is, once they run out of food, they eat each other. So they kind of self-regulate. So I talked about, the best thing is to just not discharge or when it comes to ballast water. But we touched a little bit on waste management in general. So, the ships can manage the waste on board. We're going to walk through the recycling center. You're going to see the team that does that. You're going to see the equipment that we use. We've also done a lot when it comes to just trying to reduce source minimization. So if you don't generate it to begin with, then you don't have to handle it. You don't have to dispose of it. You probably noticed already on the ship that we've reduced a lot of single-use items. Now you hear people talk about single-use plastic, but it's really more than single-use plastics. It's everything. So you've noticed things like butter pats are no longer on the ship. We've gone with small little dishes with butter in it. Bulk sugar. So anybody want to hazard a guess how many packets of sugar, white sugar, that we purchased the last full year of guest operations?
20 million?
100 million. So we went from 100 million sugar packets down to where we just have sweetener. So that 100 million was just white sugar, that you put in your coffee. The sweeteners it's very difficult to do them in bulk. So those are going to stay just because it's different. They don't hold up well when you put them out into the environment, especially with the humidity of the Caribbean. So they'll be around. You notice you don't have stirrers in the coffee bars anymore, right? You just get a spoon. You'll see that any of the coffee bars on board, we just went away. Those plastic stirrers ended up in food waste, and we just had to put a stop to that. So, it's sugar, cereals. You notice also we got the bulk dispensers for cereals rather than the little boxes. Hotels have been doing it for a while, so we decided that was going to be the way we were going to do it. Too many items for me to mention, but as you walk around the next few days, just think about the things maybe in the past you saw that has changed since then. So we have reduced, I forget the last number because it's without guests on board, it's been a little bit difficult, but like 80 or 90% of the SKUs, don't quote me on that one because I'm getting old. But it's a huge number of SKUs that were single-use items before. So, and we're not done.
Plastic bags in retail.
Yeah, so we're not using plastic bags. We've gone with paper. Just any place you can think about. Look, phone, using the Hub app. We're not, we only give you a fun times on paper if you ask for it, right? So you don't see all those collaterals in the staterooms. I remember when I first started cruising 20 years ago, at the end of the cruise, because my wife would never throw anything away until the last day and she couldn't fit it in her purse. Exactly, it was a stack like that. Because you kept every fun times or every daily bulletin, every collateral for sales, the spa, excursions, whatever, and it was that thick. And guess where it went? Right in the round file, and it went down to the room, and it became waste. Right?
Was it hard to go to some of the bulk packaging with the introduction of COVID? Because I think everybody was going towards these single, they were going and all that, and then suddenly it was like, wait a minute, using things all communally maybe is a little.
Just like things changed throughout COVID, our approach to some of these bulk things and tongs, the medical people are looking at that. I'm not a doctor. Don't play one on TV. Didn't stay at a Holiday Inn Express last night. But I think they've gotten to where, while they still encourage people to wash their hands because it's just good sense, I think they're finding that that's not the big vector for coronavirus. So, but again, we have, the ship has a public health officer on board. We've got a crack team of physicians and public health experts in-house as well as consulting with people outside. I'm sure they're watching that very carefully. So, not my